Welcome back, everyone. We are going to continue on with activity 4.1b. What I'd like to do first is go through the objectives and make sure that we know what they are and how well we've done achieving those objectives so far. So the first objective is to distinguish a simple random sample from a stratified random sample, cluster sample, systematic sample, and a convenience sample. We did that in the first video, but we are going to continue to practice with that in this video. We want to recognize the advantages and disadvantages of each sampling method based on the situation. We will do that in this video. We want to practice again with how to use a random digit table to select a simple random sample. We will do that in this video, and describe how to use various sampling methods to select a sample representative of the population. So we're going to do that as well. So if you recall, last time we left off with number 4, so we're going to pick up with number 5. And for number 5, what we're going to do is we're going to read each of these scenarios and decide what type of sampling method is used. And so let's begin. So here's an example. All freshmen at a university are enrolled in one of 30 sections of a freshman seminar course. To select a sample of freshmen at this university, a researcher randomly selects 4 sections of the seminar course from the 30 sections, and all students in the 4 selected sections are included in the sample. So for sake of discussion, let's assume that there are equal number of students in each of these sections. So let's say there's 100. Okay, so there's a total of 3,000 in the population. If there's an equal number of students in each of the sections, then each student has an equal chance of being selected. However, if we are selecting 4 sections from the seminar course, then its entire sections, and we would be taking a sample of size 400 if we assume there are 100 students in each section. That being said, not all groups of 400 have an equal chance of being selected. The only groups of 400 that have an equal chance of being selected consist of 4 entire sections. So this is not a simple random sample. However, it is a cluster sample because we've broken the population into 30 different groups, and we've randomly selected entire groups. It's a cluster sample, not a stratified random sample. In B, it says to obtain a sample of students, faculty, and support staff at a university, a researcher randomly selects 50 faculty members from a list of faculty, 100 students from a list of students, and 30 staff members from a list of support staff. For simplicity's sake, let's assume that these numbers are proportional to the makeup of the population. So, does each subject have an equal chance of being selected? Yes, each subject has an equal chance of being selected in this case. Do all groups have an equal chance of being selected? So in this case, we're going to take a sample of size 180, 50 faculty members, 100 students, and 30 staff members. Not all groups of 180 have an equal chance of being selected. The only groups that have any chance of being selected consist of exactly this number of students, 50, faculty members, 50, this number of students, 100, and 30 staff members. A group that consisted of 180 faculty members, or 180 students, or 180 staff members has no chance of being selected. So again, it's not a simple random sample. However, it is a stratified random sample. We've broken the population into distinct groups based on some criteria in this case, and we've randomly selected from each of those groups. Letter C, a university researcher obtains a sample of students at his university by using the 85 students enrolled in his psychology class. This is not a method that uses random selection, this is simply a convenience sample. And letter D, to obtain a sample of the seniors at a particular high school, a researcher writes the names of each senior on a slip of paper, places the slips in a box, mixes them, and then selects 10 slips. The students whose names are on the selected slips of paper are included in the sample. So since each student had their name on one piece of paper, each student has an equal chance of being selected, and we could, using this method, select any group of 10 students, so all groups of 10 have an equal chance of being selected. This is a simple random sample. Letter E, to obtain a sample of those attending a basketball game, a researcher randomly selects the 24th person through the door, then every 50th person that is also included. Then every 50th person after that is also included in the sample. Well, there's randomness associated with this. They randomly selected the first person, and it turned out to be the 24th person through the door, but then they select every 50th person after that. So before the process starts, you could argue that every person has an equal chance of being selected, but not every group of whatever sample size is being selected has an equal chance of being selected. Once the first person is selected, then the next person is going to be the 50th person after that, and then the 50th person after that, and so on and so forth. So a group that would consist of 2 people in a row through the door has 0 chance of being selected. Letter E is an example of a systematic random sample. At this point in this activity, we're going to take a little bit of a detour and talk briefly about some vocabulary. So let's read number 6. Ideally, if we want to draw conclusions about a population, we would collect data from the entire population. That is called a census. However, since that is typically impossible to do, the sampling methods discussed in this investigation are important to know. In all these sampling methods, we typically start with a list of subjects, or cases they're sometimes called, from the population from which we will randomly select our sample. The list that we're going to select our sample from is called the sampling frame. Ideally, we would like that to be the entire population. However, that might not always be possible. Think of sampling all the fish in the Great Lakes. Because of that problem, we find that in most samples there might be some degree of undercoverage. Undercoverage means we are not giving each subject or case in the population an equal chance of being selected, and this can lead to bias. So let's take a look at an example here. Suppose a factory can produce 1,000 iPhones per day. The management would like to ensure that iPhones produced by the factory meet quality standards. It takes about 10 minutes per phone to properly inspect each phone, so it is not practical to check each phone produced. The management decides it will inspect 20 randomly selected phones from a given day's production run. What's the population? What's the sampling frame? And what's the sample in this situation? Well, if they're going to be sampling every day, then the population is the 1,000 phones that are produced that day. The sampling frame, in this case, our sampling frame should be the same as our population. You could say that the sampling frame is a list of the population. In this case, we could say it's all the unique serial numbers for the 1,000 iPhones. And the management decides it will inspect 20 randomly selected phones. So in this case, the sample is the 20 randomly selected phones. Part B, an employee suggests that it would be easy to select the last 20 iPhones that were produced today. Discuss why this isn't a good idea. Well, first of all, it doesn't use randomness in the selection process. Secondly, the last 20 phones, well, maybe people got lazy or tired or whatever the case may be, and they may not be representative of the population. In any case, it's a bad idea to use a sampling method that doesn't incorporate randomness. Part C, another employer recommends inspecting every 50th iPhone produced today. Comment on this selection process. It seems like a reasonable way to select a sample from this population. However, we should always incorporate randomness in our process. So we would probably want to randomly pick a starting phone, one of the first 50, and then do every 50th after that so that we avoid bias. And I suspect that that would work fine. We'd have to be a little bit more familiar with the process though, because maybe there's some cyclical problems with production where every 50th phone is fine or every 50th phone has a problem, and that's not representative of the population. Maybe the equipment heats up and overheats at that point, and then it cools back off, and then it heats up, and so on and so forth. Again, we don't know the answer to that, but if we had a little bit more knowledge about the production process, we could decide. All right, what we would like to do now is to finish up this activity by practicing thinking about and describing how we would select various types of random samples. So here's the scenario. The student council at a local high school wants to conduct a survey prior to an all-school assembly in the auditorium. They would like to announce the results of the survey at the end of the assembly. There will be 800 students in the auditorium for the assembly, and the student council realizes that there won't be time to conduct a census. They decide to select a sample of 80 students. The student council asked you to decide on the selection process. A diagram of the auditorium is shown below. Note that the students are seated by grade level and that the seats are numbered 1 to 800. All right, so let's see what we have here. We have ninth graders, 200 of them. From 601 to 800, we have 10th graders, conveniently, 200 of them. From 401 to 600, we have 11th graders from 201 to 400, 200 of them as well, and 12th graders from 1 to 200. So we have equal numbers of 9th through 12th graders. Now let's look at the seating arrangement. So 12th graders are in the first 10 rows, I believe, because they are 1 through 200, and there's 20 per row. And then 11th graders are in the next 20 rows, 201 through 400. And then 10th graders in the next 200 are 20 rows, and 9th graders in the last 20 rows. What's the population, the sampling frame, and the sample for this problem? The population is all 800 students that are seated in the auditorium. The sampling frame we could think of as the list of numbers 1 to 800, each number being associated with a student. And what's the sample going to be for this situation? Well, we're going to select a sample of 80 students. So if we think about this, it seems like we would want to select a sample that, well, we always want to select a sample that is representative of the population. And if we were to randomly select 80 students, those 80 students could turn out to be all freshmen or sophomores or juniors or seniors, which probably wouldn't be a good idea. So there's an example of a situation where we incorporate randomness to avoid bias, but we have a better way of taking a sample. The better way of taking that sample would be to use a method that ensures that we get equal representation of each of the 4 grade levels. So one member of the student council suggested that they survey the first 80 students who entered the auditorium. Comment on this selection process. Well, clearly it doesn't use randomness. It's a convenient sample. It's just a bad idea. Describe how you would use a simple random sample to select the 80 students for the survey. So up to this point in this activity, I haven't been doing a whole lot of writing, but one of the things that you're going to have to be able to do for Miss Harding and myself, along with the College Board, is be able to write clear explanations of how you would do things. So in this case, we're going to do that. Describe how you would use a simple random sample to select the 80 students for the survey. So I'm going to do this explaining using the random digit table. So using 3-digit numbers, assign each student a number from 001 to 800. Read off 3-digit numbers from the random digit table, ignoring repeats and numbers outside the 001 to 800 range until you have 80 unique numbers. It's that simple, but it also has to be that clear. Somebody has to be able to read your method and reproduce your method without question. Describe how you would use a stratified random sampling to select 80 students for the survey. So we're not going to go into as much detail here, but separate students by grade level and randomly select 20 students from each grade level. Describe how you would use cluster sampling to select 80 students for the survey. Well, this one gets a little bit more tricky because when we select a sample, we always want the sample to be representative of the population. So let's go back to our diagram for this one. If we were to say, let's select clusters by entire rows, that would be a bad idea because what we could end up with is we could end up with clusters that are all freshmen or all sophomores or all juniors or all seniors. So we don't want a cluster by row. So pause the video for a moment and try and think of a way that you could cluster where each cluster is a good representation of the population. All right, if you go back and look at our diagram, if you were to break the population into clusters based on columns but not rows, and you can see I've done that in my diagram here. I've drawn in 20 columns. If you took a look at the group of 800 in the entire population, if you have 20 columns, each column would have 40 students in it. So what we could do is we could number each column. Let's say we use double-digit numbers 01 through 20, and then randomly select two of those columns to get our cluster sample, and we would take the entire group. So describe how you would use cluster sampling to select the 80 students for the survey. Divide the auditorium into 20 vertical and 20 columns, not rows. Number each column 01 through 20, and randomly select two entire columns. Okay, so this last question really requires you to think about what you want to accomplish here. Which method would you suggest to the student council and why? While the simple random sample method and the stratified random sampling method and the cluster sampling method and probably even a systematic random sampling would all work fine, the question is which one is going to be the best? And our goal is to get not only a randomly selected sample, so to avoid bias in our selection process, but a sample that is close to the population value as we could get. So there's one other thing that was mentioned here in this situation, and that was that the student council wanted to get results quickly. So in this case, I think that the stratified random sample and the cluster sample are the two methods that are going to give us proportional representation of the four grade levels. But if I were doing this, I would use the cluster sampling method, and the way I would do that is I would then pass back the information in each of the two columns and then recollect it, and I could gather that information quickly. So I would select the cluster sampling method based on columns because it will, one, guarantee us a good representation of the population, and two, it will be quick, which is one of the criteria. All right, we are going to finish up here and with a short discussion here. And basically, the idea is this, is that we would really always typically like to have information about the entire population. Most times that's not possible. So what we typically do is we do the best we can to get a good representation of the population with our sample, and then we use that information to make inferences, conjectures, estimates, etc. about the entire population. So, last thing, sampling is an important topic in statistics. No matter what method or combination of methods you use, it is important to remember that the sample needs to reflect or represent the population and must be randomly selected. Randomizing helps to protect you from bias, and it makes it possible to draw inferences about the entire population from the sample. We will talk much more about inference in first semester, and we will dedicate most of second semester to that topic.